If we could all just take one moment, look at nature, we could all use biomimicry and make a much better world.
When working with the built environment and trying to solve problems, biomimicry is a fantastic way of approaching it. It's really the ultimate design lens because nature has 3.8 billion years of research and development under its belt. When companies are looking to solve a problem, you just need to look at it from a different perspective and then ask, what would nature do here? Sometimes it's a little difficult because we as architects don't necessarily have the scientific background, but by bringing a biologist to the design table or someone who's trained in biomimicry, anyone could utilize nature's genius in their designs, whether it's working on a material, it's working on energy solutions or water solutions, or even social solutions. My name is Cynthia Fishman, and I am the director and founder of the Biomimicry Design Alliance located in Denver, Colorado. We work on research and consulting services for the design community, trying to make biomimicry more accessible. Right now, we're in the butterfly pavilion, surrounded by all these amazing plants and butterfly friends. So the problem that we were trying to solve was looking at open office environments and how it gets really, really noisy. There are all these studies that are done that actually that noise hurts your productivity, in addition to just making you upset because you can't hear who you're talking to, you can't take phone calls, and it's just really difficult to work. So the team and I started looking to how does nature manage acoustics or mitigate sound. We came across this unbelievable species called the Cabbage Tree Emperor Moth. And this moth, even though it's the size of my hand, it's not extinct, and it's because bats can't find it.
We discovered a research report that was back in 2018 about the emperor moth and how it was not being detected by bats. Bats use echolocation to find their prey. The research scientists noticed that the echolocation did not detect the emperor moth, so the bats didn't find them as a food source. So the report went into some further detail, and looking under a microscope, you could see that they were made of tiny little scales. So somehow those tiny scales that we discovered were basically absorbing those sound waves. The echoes weren't going back to the bats.
So we were able to take how the moths actually have this acoustic camouflage and create a product that could not only be used in open office environments, but also in restaurants, in conference rooms, and even in healthcare facilities where you're also looking to mitigate sound. So the proposed solution for looking into how to mitigate sound or dealing with acoustics would be to study this Cabbage Tree Emperor Moth and figure out how exactly it has this acoustic camouflage. And by mimicking the functional form of this acoustic property of this moth, we're able to create a product that deals with sound in a different way than how we typically deal with sound in the built environment. So technology played a huge role in helping us figure out how exactly this Cabbage Tree Emperor Moth has these acoustic properties. We were able to take technology that's used in the built environment and created different scripts and 3D modeled how this moth would actually function in the built environment. So by testing it in 3D model, then we also used an acoustic testing lab where we 3D printed what this form could look like, and then also used an impedance tube and lots of other acoustic testing methods. So Biomimicry Design Alliance partnered with MG Technology Partners in order to utilize their expertise with BIM and different AEC modeling software. It's because of them and looking into creating a specific script that we were able to digitally model what this product would actually look like.
So we started using a product called Dynamo, and this is a graphical visual programming interface. And it's part of a BIM program called Revit. By using this particular tool, we were able to assimilate the geometry that we saw in those images, looking at those tiny scales. And the bonus is that by producing this particular geometry using Dynamo, we were able to change the input values and get different looks or flavors of this particular panel that we were trying to produce. The other added bonus was we could take this geometry that we developed within Dynamo and plug it directly into our design, being Revit. What was great about using Dynamo is because we could take those inputs that we had and literally change the varying depths or widths or size of those tiny scales and reproduce the panel as many times as we needed. Obviously, as we went through those versions, we could also bring those into Revit to continue on with the design. By using Dynamo and developing that geometry and bringing it into Revit, we are now able to take that particular panel that we developed and we're able to array it, we're able to double up on it. So in other words, we could sit down and start designing our walls, our doors, our windows, our floor, our ceiling, and then we could take this panel and bring it in and use it wherever we wanted within our design. What was exciting is that we were using BIM-based tools to utilize the genius of nature. We not only used Dynamo to help us generate the geometry for the panel, but we also started looking around within the open forums and open source and found a package to help us do acoustical analysis using Dynamo. So this took it now into the ability to go further with our research. As you can see in these next images, what we were really concentrating on is the reflection process of this. And we really didn't look at the materials. So all of this was based on a hard material, like a gypsum board type material. So if you look at the images, what we can see here is that we have a point in the middle of the room. And what it does is it shoots a set of rays. And based on those rays, then it intersects that particular geometry and then can bounce back. And it gives you then the results of how many rays you initially started off with, and then how many rays actually get bounced back. So in our initial analysis, we just went ahead and put in a typical gypsum board ceiling. And as you can see in the image, we basically put a point out there. We shot basically a 12 by 12, which really comes out to 144 rays. So we shot 144 rays up to the ceiling. Not really surprising, 132 of them came back to the floor, but it was a really good way of setting up the baseline in a typical environment that you would probably see in most offices. The only thing that we really changed out was the ceiling. At this point, what we did is we put in our moth wing based panel. Now, this particular panel was arrayed and we did double layer it. And we did offset that on the second layer. So again, we were trying to simulate what we saw in those images from the microscope, looking at those tiny scales. Now, setting up the same package with the same logarithm, we did a 12 by 12, which basically is another 144 rays. We shot it back up into the ceiling. Now, what we were astonished though, and remember, this is a hard surface, we still do not have like a soft material applied to this, 33% of the rays disappeared. So that really kind of woke us that the research and the analysis is we're starting to see some very interesting reports coming back to us on this. We were really getting inspired about our findings from this initial analysis. And enough that we went and filed a patent. We actually did a 3D printed version of this. So it's quite inspiring looking at biomimicry and bringing this into our design process. And also looking at being 2022, looking at how this all fit within industrialized construction. Before we even knew it, we went from BIM design using Revit, Dynamo, Families, 3D Studio Max, Inventor, and getting this result. That's pretty incredible. I am Jared Schultz. I'm Director of Industrialized Construction at Team D3. I work with a team to help develop automated solutions for our product manufacturers and contractors, building and inventing brand new concepts, workflows, and processes for them.